Hello everyone, myself Nandan from AML department, 5th semester, and these are my team members Nikhil, Chinmay, and Kushal. We are here going to represent our assignment one of artificial intelligence subject. We are here evaluate our assignment one comes evaluate and propose improvements in pathfinding algorithms, A star search versus greedy west search. These are the types of search, and this is guided by uh, Shilpa ma'am, Assistant Professor of AIML Department, GM University, Davangere. And these are my team members, Kushal, Chinmay, and Nikhil. And this is our introduction where we used what is our problem statement. Pathfinding algorithms are essential in AI, robotics, and games, and A star and greedy west search, breadth first search are heuristic based search algorithms. These are the algorithms where we used, and this main goal is evaluate their efficiency, heuristic impact, and propose improvements. What are the proposed improvements we are using here? In the next slide, uh, we are going here with objectives to understand and explain the working principle of A star and greedy west for search algorithms, to compare both algorithm in terms of time complexity, space complexity, and path efficiency, to analyze the role of heuristic function in determining algorithm performance, to identify a practical application where we use algorithm perform best. Here means which the algorithm is best we have used there. To propose innovative improvements for enhancing scalability, speed, and accuracy in pathfinding, and to evaluate how hybrid or adjective technique can improve real-world pathfinding performance. These are the objective where we use in our problem statement. In the next slide, we have here working principle of A star search. There are two algorithm, A star search and greedy best breadth search. Comparing to A star search, we have combines uniform cost search and greedy search, evaluating functions like f of n is equal to g of n plus h of n, where g of n is equal to cost from start to current node, and h of n is equal to estimated cost to goal. Select node with lowest f of n, guarantees optimal path of heuristic is admissible. And in the next slide, we have In the next slide, we have here working principle of greedy best first search. Here focuses only on heuristic value evaluation function f of n is equal to h of n, expands node closest to goal, lowest h value, fast but not guaranteed optimal, can get trapped into local minima. These are the working principle of greedy best first search. In the next slide, we have here performance comparison. This will be explained by my friend Nikhil.
Coming to performance comparisons, in that aspects A stars greedy BFS. Aspects evaluation functions G of n plus H of n in greedy functions. Optimal solution yes in A star. In greedy function no. In time complexity in A star O B and D. Greedy BFS O B and M. Space complexity in A star O B and D. In greedy BFS O B and M. In aspects speed, in A star moderate, in GDBF fast, in path quality, A star optimals, in GDBF approximate. These are the performance comparisons, and these are the impact of heuristic functions. Heuristic function estimates distance to goal, common heuristics, method distance, Euclidean distance, Chebyshev distance. A star used both GFN and HFN, balanced search. Greedy BF used only HFN, faster but riskier. Accurate heuristics improves performance and efficiency. And next slide is continued by Chinmay.
Hello everyone, here is the practical use case application preferred algorithm reason. In application GPS navigation and preferred algorithm A star and reason it needs optimal route. In game AI, it preferred algorithm A star and reason smooth realistic movement and it Next application robot navigation and preferred algorithm A star and safety critically. And next application web scrapers preferred algorithm greedy BFS and reason fast exploration. And the last application search engine, it is preferred algorithm greedy BFS and reason focuses on relevant results. In next slide, we used proposed improvements. Weighted A star, it introduced weight to heuristic f of n is equal to g of n plus w star h of n. And adaptive A star, it update heuristics dynamically based on environment. And it next bidirectional A star, it run searches from both start and goal. In next hierarchical A star, it cluster large maps for faster computation. And in last learning based heuristics, it uses AI models to predict h of n intelligently. And here is the last conclusion. A star is optimal but resource heavily, and greedy BFF is faster but less accurate. Hybrid or adaptive A star improves both speed and scalability. In future enhancement, AI driven heuristics, parallel computation, and real time optimization. And next, the code will be explained by my friend Kushal.
Thank you, Chinmay. Now I am going to explaining the code part of the evaluation of A-star search and greedy best first. Here we are importing some header files like math, import math, and here the helper function we used as heuristic. It means that maintenance distance heuristic, and we differentiate neighbor and give valid four directional neighbors for the direction, and it gives the results and the results are appeared. And A star's algorithm, we have defined star and A star and come up with the for loop. Here, while then while loops are open, the iterations will continue. The current is equal to come from the current. Means it searches the path of the current from the goal. Then if a loop is started, then it appends the start path, receives, then return the path. Once it goes the path, it is root, the path should be shown. And if neighbors is get neighbor current at the if it once it's go to a neighbor, it will check all the neighbors of the current node and it returns the known. Then we go to the greedy best first search. In greedy best first search, it current node shows the all the related neighbors, and it shows, and it starts with a while loop and current is equal to it if current goal, while returning in came from path append. Then current from it shows the path reverse and then return the path. Then the current node is came from current node, from neighbor is get neighbors. If it is not, then it is not visited to the neighbors. Then visualization of A star and the greedy best first search. Here in the visualization, we know the uh, path of the A star and the greedy best first search. In main test is the greedy best first search. We used some math, so we imported math library. So we give the matrix of the data, means neighbors, then show up some, then it prints the output or a result of the visualization of the graph, shows the result in my it prints the greedy best first search and the A star search, and it gives the output. Here is the output of the A star path and the greedy best first search path. Here we know A star visualization, the graph should come from starting node to the end node, and the greedy best first search also shows the visualization of the starting node from the end of the node. Thank you, Chinmay. It is the output of the A star search and greedy best first search.
Thank you,
Thank you.
everyone.
Thank you.